Okay, today what we're looking at is dilations. The dilation is a transformation that enlarges or reduces the size of an object by a scale factor, which we will know as K. This is kind of like when you get a picture, and you can either enlarge the picture or you can shrink the picture. That's a dilation. So if you take a document and you find a picture online that you like, and you paste it into a Word document or something like that, when you enlarge it or you shrink it, you're really doing a dilation. So what it's saying is that every point x, y, every point is going to get multiplied by the scale factor, which is k. So k times x, or k times y, and k times y. So you multiply every single point. So if I have a scale factor and I want to enlarge it, I'm going to multiply by a number greater than 1. Anything that's greater than 1 will enlarge the object, will make it bigger. If I want to reduce it, it's going to be between 0 and 1, some sort of like fraction or decimal. It's not going to be 0 because 0 would wipe it away. It's not going to be 1 because if I multiply something by 1, nothing changes. So if I take a look a little bit here at this graph, at these two graphs, what I have here is when I enlarge it, see, it's getting bigger. Now I know it's kind of hard to see here, but what they did is they took every point and multiplied it by 2. So they made everything 2 times bigger. So they took every number here and multiplied it by 2 to get the numbers that are over there. Now in this one, they have a scale factor of 0.5, which is the same as 1/2. So here they took every one of these, multiplied it by 1/2 to get there. They shrunk the object. So when we're doing the scale factor, we're either going to enlarge it or shrink it. Again, you enlarge when you multiply by something bigger than 1. You shrink it when you multiply by something smaller than 1, but also bigger than 0. So here we're going to find the coordinates of the vertices of each figure after a dilation with a given scale factor k, then graph the image of the dilation. So let's look at our first one here, which is k equal to 3. So it has a dilation of 3. So that means everything is going to get multiplied by 3. So I go 2 times 3, which is 6. I go 1 times 3, which is 3. Do the same thing here. 3 times 3, that becomes 9. 3 times 0 is just 0. And then lastly, 3 times 1 is 3. 3 times 2 is 6. But because that 2 is negative, that becomes negative 6. Now I graph these points. So I go 6, 3, 1, 2, 3, 4, 5, 6, up to 3, 1, 2, 3. And there's my A prime. That's that new point, so it moved from here to here. Now, I know this is 3. I'm actually going out to 9. So 4, 5, 6, 7, 8, 9. There's B prime. And then the next one is 3, then negative 6. 1, 2, 3, 4, 5, 6. There's C prime. Then I just connect the point. I get the same figure, just larger. So that's what I'm doing with that one. Now here, the scale factor is 1/2. 1/2, or 0.5, is the same as multiplying by 1/2. So if I take this one up here, which is at B, I'm going to have 4 times 1/2 and 5 times 1/2. Well, 4 times 1/2, that's 4 over 1, becomes 4 over 2, or just 2. 5 times 1 is 5, 5 over 2, which I'm going to make 2.5. So this is 2, 2.5. Now I come to the S. Well, that's 2 times 1/2, which is 2 over 2, which is just 1. And the people who are really paying attention and sort of figured it out here, when I multiply by 1/2, it's really the same as dividing by 2, because the 4 divided by 2 is 2, the 2 divided by 2 is 1, and that works as long as your numerator is a 1. You can divide by that denominator. Now I come to here with letter L. If I notice I have that 5 which I had there, that's just 2.5 and 0. So I want to graph B. I go 1, 2, then 1, 2, 3. 2.5 is right in the middle of 2 and 3. Then 1, 1 is right there. There's S prime. Then 1, 2, 2.5. There's my L prime. And then there's my same triangle reduced. Scale factor really just is about reducing or enlarging the size of the object by multiplication. Now, the hardest thing that could happen for some of us is if the scale factor is k is something like 2/3. And if I had something like 3, 6 as my point, well, all I would do is say, well, I can't divide by 3 because this is just because that's not a 1. If it was a 1, I could divide by 3. So I just take 3 over 1, which is this, times the 2/3. That becomes 6 over 3, or 2. Then I do the same thing here. Oh, that's 6. 6 over 1 times the 2/3, which is that scale factor, which becomes 12 over 3, which is 4. So I can put that there, so it's 2, 4. So that gives you a little thing to do if that scale factor, I'll move this over, isn't as nice and neat as like 1/2 or 1/3 if it gives you a fraction. But all you're really doing still is just multiplying. The scale factor is all about doing multiplication.